This problem helps students to refresh their memory about the response of a linear dynamic systems. To solve this problem, students need to use two concepts. The first one is the convolution integral, and the second one is the Laplace transform integral. The convolution integral comes from the idea of uh, the response of a system to impulse input. Uh, to calculate or to estimate the response of a linear system subject to a random input, we can assume that input is a summation of the consequence impulse inputs, and the output of the system, according to the superposition concept, is this for a linear system is summation of the all responses subject to these consequence inputs. If you look at the lecture notes from control module, you can see the definition of the convolution integral. According to this lecture note, the convolution integral is y of t, which is the integral from minus infinity to plus infinity ht minus tau u tau d tau. U tau is the impulse input, and or in fact there is input function, and ht minus tau is called the impulse transfer function. So interpretation of the conventional integral is that the response is the sum of the responses to individual impulses. So to solve this problem, the first relation or integral that you need to use is convolution integral. The second relation or formula you need to consider is the definition of the Laplace transform. According to this lecture note, again from control module, the Laplace transform is defined as the integral from 0 to infinity of f of t e minus st dt, which s is the s plane variable or s domain variable, and is a complex variable as a sigma plus a j omega. To show that the part A of the problem is valid, you need to use these two concepts, the convolution integral and the Laplace transform integral. To solve the part B of the problem, you need to use the result of the part A, and again use the superposition concept in order to show that the response of a linear system subject to the sinusoid input is as shown in the part B.